all of the distinguished speakers on the dais, as well as all my colleagues in front of us as audience. So I belong to LNG sector and coming from Petronet LNG Limited. Here in my presentation, I'll try to cover some of the incidents and the learnings which we have from those incidents. Since I am coming from LNG sector, LNG traditionally is being seen as a, you can say, B2B business. Now, as a product, it is traveling to different CGD areas and being dispensed into the LNG, LCNG stations. So, safety of LNG sector has now come to a public arena, you can say. Earlier, it was considered as natural gas only. My whole, you can say, 10 minutes talk will be on LNG safety, which is little bit different from the natural gas in terms of cryogenic nature and all. Actually, every incident that happens that affects people, environment, assets, and reputation of the company. So, incidents should be avoided. And we have an incident triangle that I have shown here. Actually, in our plants, we follow this kind of procedure. This accident triangle theory was evolved, you can say, first Bird suggested it in 1969, where it started from near misses, and if we report 300 near misses and acts on these 300 near misses, we end up with a one major injury. And if then further theories also came up. So in ConferenceCumExhibition theory of 2003, they have now reached to the risk behavior actually. They have now downgraded it to, you can say, unsafe behavior and unsafe conditions that are occurring. If we are reporting about 3 lakh unsafe incidents and acting on those incidents, for example, if the road is not correct and we are walking, and incidentally our foot stepped in, but we do not fall. That comes as a, you can say, a near miss. Before that, if somebody see that road is not correct, he is able to see it. That is called actually the risk behavior, or you can say at-risk condition. So in our plants, we are now looking into the behavior as well as at-risk conditions that are occurring. Actually, in LNG industry, there are many standards through which it has been designed. So, as far as B2B is concerned, there are not much incidents that has been reported in the LNG plants in India. LNG terminals, Petronet LNG is having Dahej and Kochi, and IOCL in Ennore, and other players are also there in Shell, Hazira, and all. Some of the incident history that I just want to show is, one is very old, 1944. This is actually a peak shaving plant in US. Here, at that time, 3.5% nickel steel was used for construction of LNG tanks, which is at minus 160 degree. Due to that material failure, it was a major catastrophe, and about 160 deaths were reported in this case. The lessons learned were that we have to work more on changing the material of cryogenic material, and later on it was changed to 9% nickel. After that, no major incident of this kind has been reported. Then one more incident occurred at a facility called Skidda LNG, which was in Algeria. This was a spacing kind of incident where actually an intake fan for the boiler was stuck with the gas cloud, and it was burst. Actually, facilities must be designed with adequate separation. Here in India, we are using OISD standards called 118 for equipment spacing and plant spacing. Since the triggering of the incident should not blow off the nearby equipment, that is the basic concept. Due to paucity of time, I'm not explaining much. This one incident was Freeport LNG. A pipeline was overpressurized. In LNG, actually, if it is trapped between the two walls and there is no Meyer or a TSV, you can say temperature safety valve to release the pressure. Actually, it's a boiling liquid. When it is trapped between two walls, the pressure starts increasing, and after some time, if there is no means to release that pressure, then the pipeline can burst. This was that kind of incident. After learnings from these incidents, all the blocked pipelines of LNG are being designed now with the TRVs. Then this is the single incident of LNG rollover which occurred in La Spezia, Italy in 1971. Rollover means actually LNG, when we receive from ships, it is coming at different densities. And if we are not loading it properly for mixing, the layers are being created and lot of boil-off gas is generated, which is unhandleable actually. So that kind of incident we can avoid by operational controls and loading the LNG that is coming from the ships in the, you can say if heavy LNG is coming, we should load it actually at the top so that it mixes and goes down. So that kind of operational control we are following to avoid rollovers in our plants. One more safety incident of Hammerfest LNG Limited. This was a deferred maintenance kind of incident, so this I will skip actually. This is one of the LNG ship which grounded due to, grounded on a rock actually. The ship was, the ship outer hull was damaged, but the product was safe actually. This validated the double hull design that is being used for LNG ships. This is actually the table comparing all the incidents that I have just spoken about. First is Cleveland. The lesson learned is the material chosen should be right for every service. Then the congested layout, the layout should be as per the standards that are being defined. In India, OSD 118 is being defined in the petroleum rule as well as SMPV rules for equipment spacing. Then for actually the maintenance deferment issue also, and in LNG particularly, it should not be blocked between two walls. These are the learnings from these incidents. Now I'll come to one incident in India which is in public arena, like now LNG is going to the public arena and it is equivalent to CGD, you can say. This station was created somewhere in Madhya Pradesh. So one leakage occurred here. Incident was LNG leakage from high pressure pump, LCNG pump. These type of pumps are now being installed at many places. About, you can say, 35, 40 such stations exists in India. And these are increasing more and more. People are bringing in more stations to monetize their CGD area where pipeline cannot reach in that particular time. So leakage was first observed on 23 April. The storage tank contained approximately 35 ton of LNG, and duration of leakage was quite large, about 7 hours it was leaking at a slower rate, and when the inventory was totally finished, then only the leakage could be stopped. No casualty, fire, nothing property damage was there, but this is the incident which tells us that this kind of things we can avoid. Here the arrow that you can see, that red arrow, here one hose is being used. Actually LNG is at minus 160 degree. And for expansions inside the smaller pipelines, smaller hoses are being used. So this hose got damaged, and due to damage of this hose, LNG started leaking. So after, when the LNG started leaking, the spray of LNG was towards that red wall, that is a ESD wall actually. When there is a leak, the gas detector will activate and these walls should stop and preserve our inventory. But what happens in this case, the LNG started leaking and a lot of vapor cloud was formed. The primary failure was created due to initial component failure. The return line flexible connector of HP pump loading started leakaging. Then delayed detection. Actually, hydrocarbon detection should be very quick. But in this case, the TSD detected gas detector detected the leakage after about 4 to 5 minutes. The delayed detection meant large vapor cloud form leading to icing of the return emergency. This red valve was completely iced because of LNG falling directly onto its actuator. And this valve, after ESD activation, it could not be closed after receiving the closure signal from the instrumentation also. So this valve kept open and lot of fog was there and people were not able to see anything. So manual valve after that also, they were not able to close because they were not able to see from where the leakage was going on. The failure of the return line ESD valve to close meant the liquid LNG could not be contained, resulting in continuous uncontrolled release of nearly whole the tank inventory. About 35 tons of LNG was released from this hose leakage. So the primary lapses was hose failure. Actually, hose should be tested as per frequency defined in OSD 194, and flexible hose testing was not done in this case, and visual inspection records were also not found. I was also actually one of the investigator along with OSD in this case. Since the inventory loss was quite high and there was nearby roads, so this incident they reported it as a type 3 incident, and this was informed to OSD, and one investigation group was formed. So detection delay was one reason. Then aged sensors. The sensors used were catalytic type of sensors that took about 4 to 5 minutes to detect the leakage. Then valve got iced, and then detectors placement. The gas detector were not placed as per the dispersion analysis. The problem with these smaller plants is that we are not performing much studies on this actually. These detectors are being placed at 2-3 fixed locations without having dispersion and other studies. So this is actually same thing which I have explained. So the root cause analysis was component failure. This is hose. Then maintenance deficiencies. Hose was actually not tested. Then detection failure. Then ESD valve failure also. Here in this case, we have suggested that these kind of ESD valves should be fire coated, that it should be protected from LNG falling directly onto it. So flexible components in the LNG system should be tested at the frequency defined, and cryogenic protection of the safety instruments like ESD valve should be there. So with this, I think my time has already crossed, so these are only general slides. So thank you. Thank you.